Hi everybody, here we are today working on section 9.5, 9-5 called Classes of Functions. If you look at those pages in the book, page 499 and 500, there are, nine different pictures there. We'll talk about it in a minute, but those pictures are not all the possible pictures, but those are the ones that are going to be talked about on this assignment. So let me give you the big picture here, because if we don't have a kind of an idea why we're doing this, it might seem a little futile, but let's take a look at the big picture. All right, the whole idea is that what we do in math has some applications in the real world, and generally, as you've discovered in your science class, you collect data, and oftentimes that data will be found in a table of some kind, an XY table. You collect that data, and that data might be something, like, time versus, maybe time versus height or something, time and height, or maybe that data you're collecting has to do with a certain, chemistry and, how long something is, being heated up, or the temperature versus viscosity, some relationship between two things. And when we have all this data and it's written on a table, it might look something like this, And sometimes just looking at the data on the table, you can kind of see maybe a pattern, but sometimes the pattern is not real clear. Well, the idea here is that a picture is worth 1,000 words. If I was to plot all of these points, and by the way, this picture that I'm drawing is not the picture of this table here, but let's say I plotted a bunch of points and I found something that looked kind of like this. And I might not see the graph that looked like that. It might look more like this if I was to graph it. It might look something like this, and the dots are kind of spread out a little bit. But if I look at the basic pattern here, the shadow of that, I can see that there's kind of a curve here. And once we have an idea that the data creates a particular pattern, this particular curve suggests a function. We are going to interpret this data so that it's suggesting some sort of function. And then we have to know what type of function that is. Now, I'm running out of room here, but I'm going to slide the whole thing over here. Watch. Okay, so we now have interpreted our data, and we have to get an idea what type of function that is. And so we learn the names, and one of the things you're going to do on this assignment today is to take a look at curves and straight lines and so forth and interpret them so you know what that name is called. Now, I happen to know that this particular name is the square root function. I recognize it by its picture. A picture is worth 1,000 words. So I can see that this is a square root function. And, there's all the different pictures in your book, and they all have different names. So you're going to need to be able to recognize the picture and give it a name. And then finally, once you have a name for it, you have to recognize the basic function. What is the algebraic version of that? The basic function. In other words, the simplest version of it. And I think I'll write the word simplest up here because there's all kinds of things we can do to the function, but the simplest function, well, a square root function is basically this, okay? The square root of x. And so if I have a table and I plug in values for x and I get y values, I will have a function that I know how to write an algebra function. I can write an algebra. So once again, we start with the picture. Actually, we start with the table, which helps us create a picture, which then helps us to understand the basic shape. We give it a name so we know what that name is, and then we recognize, oh, the square root function is this one. Okay. Now, there's another step that goes beyond this as well, and here it is. So once we know the name of it and we have a basic function, then we have to figure out, well, what is the exact equation for the function that we have selected. And many times we'll do that by using the graphing calculator, but we also need to understand all that comes with what's called transformations. And transformations is where we take a function. Let's just take a simple linear function. Oh, let's just take this one we've got here. Y equals the square root of x is the basic function. Well, what if I add 2 to it? Well, what does adding 2 do to a function? Well, the adding 2 causes it to shift up. Well, what if I subtract 2 from it? Well, that would cause it to shift down. Well, what if I were to take the function and multiply it by 2? Well, that would cause it to stretch the thing vertically. Okay? What if I put that 2 under the square root? Put it under here. Well, that would actually cause it to squash it. Whoops. Actually, that would cause it to stretch it horizontally. So all of these transformations you're going to learn in pre-calculus next year. But at this point, we're at the point where we need to understand how to take a picture and figure out what the basic function is for them. And they're all found on page 499 and 500. Let's go take a look at those from your book. All right, here's the ones on page 499. As if you read what's underneath them a little bit, that'll help you understand what these are. We have seen all of these this year except for this last one down here, quadratic function. This is chapter 6. And I haven't covered chapter 6 yet because we need to go back and finish chapter 5 first, and then we'll come back here. But you may recognize this as a parabola. We'll talk about it in chapter 6. But all of these functions have basic rules to follow. You can read it under here, but let me just state them quickly. A constant function is y equals a number. That's because the y stays the same always, okay? A direct variation is the same as a linear equation that has its origin at 0. See, it's starting at 0 here. So it's been transformed by multiplying by 2, making it a little steeper, but it hasn't been shifted up or down. A direct variation and a linear equation are pretty much the same thing, but linear equations can also be shifted up or down or left or right or something like that. But in general, a direct variation is a linear equation. The identity function is simply where y is equal to x. There's nothing more to say about that, where the y value and the x value. It always creates this 45-degree angle. You remember greatest integer function? You may not have liked it very well, but it's this step function that allows us to jump whenever we have. And this comes in handy in things like how much it costs to use a cell phone. Well, you pay by the minute, or how much you're paying for a parking garage. You go into a parking garage, you'll pay so much for the first hour and then so much for the second hour and so forth. The absolute value function, that was way early in the year, and it's a V shape. Sometimes that V will open up, sometimes it will open down, depending on the transformation that's occurred. It'll shift up, it'll shift right or left, but that's the basic function. It's got the absolute value symbols on it. And then the quadratic function is always where x squared is involved. And there may be other transformations that occur. You look at the formula down here, ax squared, x squared has to be in the function. And then there may be other things that happen to the graph, shifting it or making it, squashing it, stretching it, or whatever. So all of these functions, you've got to just recognize by the basic shape that they have. Let's look at the next page, 500. All right, these three at the top of page 500, there's that square root function that I showed you a little bit earlier. And then the rational functions are what you're working on at this moment. And they tend to look like curves, although they could be different. They could have holes in them. In fact, they could be straight lines. But generally, a rational function are these kinds of curves, where there's a fraction involved in the function. And then the last one over here is basically a variation on the rational functions. But the only difference here is an inverse variation has to have the x-axis and the y-axis are asymptotes. So yes, this is a rational function as well, but it's a very specific kind of rational function. Rational functions may shift up and down and so forth, but an inverse variation simply has x on the bottom and the y-axis and the x-axis are your asymptotes. Now, these are 9 of the functions that you are dealing with this year on this assignment. You haven't dealt with square roots yet, or excuse me, cubic quadratic functions yet, but I think you can figure out what to do with that. Now, there are other pictures that aren't on here that you're going to get in pre-calculus. Let me just show you a couple of them. All right, once again, these shapes are determined by looking at a plotting the data of your science project or whatever, and you will see a shape kind of emerge. There's some other shapes that do occur that we don't have on this assignment. For example, you'll see functions that might look like this. They tend to look like this. And that is the function of usually population. A population will grow when the food supply has to do with food supply versus population. It has to do with the food supply. As the food supply increases, so does the population. But once the population is so high, the food supply starts to run short. So this is a graph, for example, of population. It has a name which you aren't going to remember, but it has a name to it as well. Also, any kind of waves that look like this, sound or light, or the waves on an ocean, or vibrations of any kind, motors and anything, these are all trig functions, trigonometry. And trigonometry is things like sine waves and cosine waves and other types of functions. So there's lots of different graphs that you can look at, and as you plot the data, whatever that data looks like, let's say the data looked kind of like this, and you look at that and go, oh, you know what? That looks like it's a trig function, a sine or a cosine curve. And then you can write your function based upon that. Now, the graphing calculator gives us a little help on this as well. You aren't going to have to use that now, but you will in the future here in the next chapter. So let me just show you real quick what that looks like. All right, there is a place in your calculator, and we've already been in here earlier in the year, particularly when we dealt with linear equations. There's a place in the calculator that allows us to go and actually create functions from data. So if I went to Stat and hit Calc, we've seen this menu before, Stat Calc menu. For example, number 4, in the past, we've done linear regressions. That's a line. If you've got a bunch of data and you want to figure out where the line is, you'd use number 4. Number 5 is quadratics. If you see a parabola and you want to go ahead and see what the equation might be, you can use that one. Cubics, we may not get to that this year. Quartic regressions and so forth. There's some others at the bottom down here. Here's a natural log regression, and there's another one, exponential regression. That curve that I showed you about population, that's called logistic curve. Here's a sine curve, that's trigonometry. So all of these curves can be calculated if you have a bunch of data and you want to say, this looks like a sine curve, or this looks like an exponential regression. Let's go ahead and calculate the equation in that particular, of that shape. By the way, the word regression, R-E-G here, just means that the calculator keeps looking back at the data. Regress is to look back at something. It looks back at the data to try to interpret what this particular picture is going to look like. And then it creates the shape that we are, as a human beings, are interpreting it to be. Now, this is a big part of doing science, is understanding that the human element here is we've got to interpret the data, and so we know which one of these particular pictures we're going to be looking at. So this assignment today is not something small. It's about being able to recognize, oh, what shape am I looking at? What's its name? And what's the basic equation of those shapes? So let's take a look at a couple problems that you're going to have today. Okay. So here's the first few problems. I'm not going to spend too much time on this because most of you can figure it out pretty quick just looking at the pictures. You have 9 pictures to pick from. And not only are you supposed to name some of these, you also have to identify the correct equation. So let's look at number 4 here. Well, I can see that that's obviously a step function. And your book calls it different things. It calls it a step function. It calls it a greatest integer function. You could call it a step function as well. This looks like a rational function. In fact, it looks like the x and y axes are both my asymptotes. So yes, it's a rational function, but more specifically, this would be an inverse variation function. You could put both answers down. Probably the latter of the two is probably better, an inverse variation. This one, because it's a flat line, is a constant function. So you go through here and name these. Now the next section here asks us to actually look at the picture, figure out what the name is, and then figure out what the basic graph would be. Now these graphs, you're only looking at the most predominant thing in them. For example, look at A here. The 3 doesn't mean much, and the 2x doesn't mean much either. The big deal is that x squared is telling me that that's a quadratic function. B, this 1 is a transformation of the problem, but a basic thing here I see is that this is a square root. And this one is a fraction. That looks like a rational function. Because the x and y asymptotes are the x and y axis are not the asymptotes here. The vertical asymptote here is -2, by the way, and the horizontal asymptote is 1. I can see that this is not an inverse variation, but it is in fact a rational function. And this is that step function feature. So as we look over here and we have to match, well, that's a rational function, and that would have to be C. And number 8, well, that's that square root curve, so that would have to be B. So you need to be able to know the names and be able to figure out what the basics are. The important part here is that this is a fraction with x on top and bottom, or just at least an x on the bottom. This one has a, the fact that this has a, a greatest integer symbol there. This one has a square root symbol, and this one's x squared. Those are the things that tell you. So look at the instructions as you're reading through this. Do the best that you can. I'm sure you're going to do just fine with this. Let's All right, let's take a look for just a second at number 37. This takes us all the way back to the data collection in your science class, okay? As you study this, you see a bunch of numbers here, and right now it just looks like a gobbledygook of a bunch of numbers. But if you need to, you could plot these points and kind of see the shape that they lay out for you. If you can't really tell just by looking at them, just quickly plot the shape, and you will see that I think one of these is absolute value, and I can see one of them is a square root function, and I can see that one of them is a quadratic function, it looks like. But you can tell if you have to plot the data which of these functions it is. It asks you to name the type of function. So you're going to be working with names and the basic equation. What's the simplest version of that particular equation as you look at it. So here's your homework for tonight. All right, so here's your homework for tonight. It's assignment U, section 9.5, page 501. I'm giving you all the odd ones here, except there's just one even problem in there. But you're going to depend quite a bit on the pictures in the book to get you going on this. Hopefully you get those things all logged in your brain, so you have a pretty good idea what shapes it performs, what name, and what's the function, what's the value of that equation. So enjoy that, and I will see you later.